to be the subject. But you can see it's actually a fine slice, right? So just to show you that there's a good degree of control with the robotic arm and good feedback. So when the knife touches the cake, you will know it's touching something. So you'll have a haptic feedback. And latency is important, especially from a medical perspective, because if it takes 2 seconds for you to feel that feedback, but if you feel it in real time, then you can conduct precise surgical operations. And it has to be a good quality video. Otherwise, you'll end up operating on the right eye instead of the left one. So these are some of the use cases we've done on. And we also we showed this to a surgeon at a National Health Service NHS event in London. They invited us. We did a demo there. A surgeon walked to me, a robotic surgeon, and said, "Is there a way that we can use technology?" Because he tried it, and the feedback was excellent. It was real time. He said he wants to use it to teach their students on hand-eye coordination. So they don't have to use the expensive equipment. They don't have to go into any hospital and break their equipment. They can use a low-cost system like this to teach students how to operate robotic devices. Because you really need a good hand-eye coordination to be able to operate these kits. So here's another video colleagues at the university worked on, and it's using robots for social care. So I'm going to play it. So where's the cursor?
The RoboGuide project develops an assistive robotic dog to help blind persons navigate indoor spaces.
When we are developing something like this, it's a mixture of several things. The first challenge is how to learn the environment.
Privileged to be invited along here, along with our partners RNIB, to test out some of the various pieces of kit that the university are developing. So it's all with a view to improving life for people with sight loss.
100%, I would use this in the future personally, as well as there's a lot of people I know that would definitely either want to try this.
Yeah, so this was a participant of the study. Is blind. And my colleagues designed a guide robot. They call it RoboGuide. And the idea is you go to a museum as a blind person, you obviously can't see anything. And it becomes very difficult for you to navigate your way around that. And possibly even expensive to have a guide in you around. So they came up with a RoboGuide. The robot dog knows where all the artifacts are, and the next. Sorry, I really can't see. Okay, yeah, so the next video is for social care as well, where we utilized. A different robot. So I'm sure you guys have been following this Dynamics robot. So we have quite a few of them in the lab. And it's for social care, helping people who can't take care of themselves at home, due to incapacitation for whatever reason. So that's the robot dog doing laundry for the person at home. Yeah. Helping out with basic stuff around. So the robot was trained within the environment, so it knows where everything is. That's it, getting stuff out of the oven. And it can be programmed to work in any environment to perform tasks like this. So we've done stuff beyond social care. So if, let's say there's nuclear decontamination, you can't send people there, or search and rescue missions. These robot dogs could be programmed to go and help out. Okay. Yeah. So the next use case that we'll look at is now a lot of hospitals are adopting technology. It's very slow. They always complain about costs. So good to know it's not just Nigeria. And there's a lot of bureaucratic bottlenecks, by the way, to get them to technology. But you can use IoT. So these are sensors that can be used to track and utilization of hospital equipment. It can be bed space utilization, how many beds are available, which beds are most commonly used, the temperature of the rooms, for instance, the humidity, the air quality of the and other equipment. You can also monitor patients using the wireless sensors and including staff protection. So some medical personnel could be under so much stress. Well-being is also monitored. So lots of different applications of Internet of Things within the hospital. And within the University of Glasgow, we implemented a simple use case using very cheap tags. So these are RFID tags that cost about 1,000. So you place it on a device. In this case, we just placed it on chairs in a meeting room. But these can easily go on hospital beds or other equipment, and it gives real-time utilization. So if someone's sitting on the chair, it will show someone is there and for how long they've used that chair. So we tried a similar technology in our lab because since to a hybrid work from home today. Okay, so yeah, so the idea is we'll have fewer workspace we have because no of desks within the lab. So we reason where the heaters are during winter. So just from the pattern we saw, which didn't make sense. If it's cold, you should be next to the radiator, not away. Turned out that the radiators just use the data we investigated, and then we reported to the facility. Technologies, the equipment, those that need constant maintenance or increasing because they are constantly being utilized, or if you need to move equipment around the university for better options. So the next is virtual wards. I'm sure quite a lot of you are familiar with this. It's basically you go to the hospital or they diagnose you, medical term. So they check your whatever, and then, for lack of better term, and then instead of admitting you in the hospital, they ask you to go home. But then they put you wearable sensors that constantly check your vitals and any other that they want to. So you go back home, they're getting real-time data, in your performance, your recovery, and if there's any flags within the system, they can quickly send someone over to have a look at you. If you're fine, if you're good to go,